for our second example, we have a question that says determine the coefficient of the term in x to the 7th in this expression. So we have a binomial being raised to a power. Now, for questions like these where they want a particular term, we're going to be using a formula that gives you any term in the expansion. And the formula is t subscript r plus 1 is equal to NCR a to the n minus r times b to the r. So if a question comes that requires a particular term, this is the formula that we use to generate the term. Now, if you want, let's say, the term in terms of its position, like the fifth term for argument's sake, you would plug in r as 4, so that would give you t5, right, the fifth term. And then you'd plug it in here with your a, b, and n, of course, and it would find you the fifth term. But this question did not ask us for a particular term in terms of its position. It wants the x to the 7th term. It didn't tell us where it is, if it's in the 4th position or, if it's the 5th term. We don't know. So we're going to ignore the left part because the left part usually indicates which position the term is in. We're going to just look at the right side, and we want to make sure that this equates to an x to the 7th term. So we're going to take the right side, which is NCR. N in this case is 8. So 8CR. We don't know what R is because we don't know what position the term is in. So NCR times A, which is x squared, raised to the n minus r, times b, which is negative 3 over x. Be careful with that negative sign. The b would actually be negative 3 over x because this would be a plus, and then you have b, right? So x squared plus negative 3 over x. So the b is actually negative 3 over x. And that is raised to the r. Now, what we want is for that term to be equal or equivalent to a constant times x to the 7. We don't know what the constant is. That is what we're trying to find, because that constant would represent the coefficient of the x to the 7th term. But we know we want an x to the 7th term. So we're going to equate them, and then we're going to get their x's equal to each other. For now, we're going to ignore the constants, right? We just want to find a way of combining the x's on the left so that they equate to x to the 7. So for now, I'm going to ignore the constants and work just with the x's. So 8CR would be a constant. If we knew what r was, r is a number. 8C, whatever number, is going to give us a constant. So we can ignore the 8CR. We're going to need the x squared to the 8 minus r times, I'm going to ignore the negative 3 as well in the bracket, which means all I have is to deal with for now is 1 over x. And I'm going to ignore the a constant. Right? So I want, when I combine these x's, I get an x to the 7. So I need to find the r value that will give me x to the 7. So let's use our knowledge of indices. X squared to the 8 minus r is x to the 2 8 16 minus 2r times this 1 over x. I'm going to rewrite it as x to the negative 1 which means, using our indices rules again, this is x to the minus r And then since we're multiplying two things with the same base, we're going to add their powers. Right, so here we have x to a power being equal to x to a power, which means the two powers are the same. So we're going to equate the powers. And then solve for r. 16 minus 7, 9 divided by 3. Our r is 3. So using r as 3 in this will allow us to generate the x to the 7th term. So I'm just going to put it over here. So therefore, so I'm plugging r in as 3, into this. So 8c3 times x squared to the 8 minus 3 times negative 3 over x to the 3. And let's work this out and see. Well, we are expecting to get an x to the 7th term, and then we'll read the coefficient from that. So 8c3 gives me 56. This is going to give me x squared to the 5 times negative 3 cubed is negative 27 over x cubed. Indices rules, this is going to give me x to the 10, 2 5s 10. And you can clearly see here now, using indices rules again, that you would get an x to the 7, because division, same base, you subtract the powers. So 10 minus 3, and we get our x to the 7th term. This is 56 times negative 27, which is negative 1512 x to the 7th. So that's your x to the 7th term. Therefore, the coefficient is negative 1512.